lots and lots of titrations, you understand. But titration basically means what? Titration basically means to find the unknown value, to find the unknown concentrations. That's what you understand by the term titration. You understand?
Yep.
So when I'm saying, titration, so it's very, very simple. What is the setup you understand? The setup is something like this. The setup is you take a beaker, okay? And here you add the acid or base, whichever is concentration you want to find. It could be an acid, it could be a base. So for example, I add some acid. Let's suppose the acid is HCl, right there.
Yep.
And here there are lots and lots of indicators. There are lots and lots of indicators. So indicators here are what? Indicators here could be, you know, litmus. Indicators here could be phenolphthalein. You understand?
Yep.
Indicators here could be methyl orange.
Yep.
So these are the indicators that we have. And what is going to happen here with the indicators? So we have the acid. And here, let's suppose we know that phenolphthalein, the natural color of phenolphthalein is colorless. It is actually colorless. Okay?
Yep.
And in the presence of an acid, it still remains colorless.
Yep.
Okay? But when you add a base to phenolphthalein, it becomes pink.
Yep.
It becomes pink. So what am I going to do? I'm going to take the acid, and the acid is generally transparent in nature, like water, and I'm going to add some phenolphthalein to it. So I must have mixed some phenolphthalein into it, but you can't see this. Why? Because phenolphthalein is also colorless. Phenolphthalein is also transparent. So now we have this particular solution here, and this solution has acid in it, and this solution has an indicator in it. What is an indicator? Which is trying to tell me whether a substance is acidic or basic. Understood or not, dear?
Yep.
Right? Now, when here we are going to talk about this particular part, just see. So, what is happening? Just see. And now I'm going to take a setup. I'm going to take this particular, you know, a stand or so, something like this right here. I'm going to take a stand here. I'm going to put this beaker over this stand. I'm going to put this beaker over this stand. So this is the stand, the slab, and I have this particular, you know, this particular stand right here. And this stand is going to do what? This stand has a handle here. This stand has a handle here, under which I am going to have another calibrated burette. This is called as my burette. This is called as my burette. You understand? This is burette. And this burette is actually calibrated. Calibrated as in it has certain markings onto it. It has certain markings onto it. Are you understanding? So the markings would start from 0, 1, 2, 3, 4, 5. And these are what? These are mLs. So if let's suppose this is a 500 ml burette, so my last here reading would be 500 ml right here. You understand, Dia,
Yep.
right? So what is the setup? The setup is like this. So we have a base and we have a base. Are you better now? You understand what moles are?
Yes.
Okay. So now understand. So let's suppose I have HCl solution plus NaOH solution and I mix them. So I know definitely NaCl plus water is going to be formed. Are you understanding? Because HCl is going to break like H plus and Cl negative. and NaOH is going to break like Na plus NOH negative. Are you understanding? So the
Yep.
positive shall go with negative and the positive shall go with negative. Are you understanding?
Yep.
So when positive goes with negative and the positive goes with negative, this is going to be my neutralization reaction. So let's suppose I have the HCl solution as suppose 60 ml solution. So you understand that this 60 ml solution has some water as well and it has some HCl as well. So then both of them adds up to form the solution. You understand?
Yep.
And according to my equation, Dia, according to my equation, if I have 1 mole of HCl, so that for that I would require 1 mole of NaOH. If I have
Yep.
1 mole of HCl, I would require 1 mole of NaOH. So thereby I will have 1 mole of NaCl and 1 mole of water being formed. Are you understanding my point?
Yep.
So what is my point right here? My point is that there is a possibility that when I am taking 60 ml of solution, you know when I am taking 60 ml of solution, it depends to what extent I have diluted that solution. It could be what? It could be that I have taken, let's suppose, zero point 0.4 moles of HCl only in 60 ml solution. That might be some solution like that. And so total moles of HCl that I've dissolved is zero point 0.4 moles of HCl in 60 ml solution. Are you understanding?
Yep.
And in the NaOH solution, what am I doing? In the NaOH solution, what am I doing? Let's suppose the solution that I'm taking to neutralize the HCl solution is, let's just suppose, the kind of solution where you have, 2 moles of NaOH in 200 ml solution. You understand? So
Yep.
basically, you understand it this way. So for example, if I say that, I am creating a solution, and in that particular solution, there it is not a pure HCl solution. It's not pure HCl. HCl and NaOH and any acid or any base can never be pure. Understand that. It will have some amount of water dissolved in it. So now when I say the solution, so I would say, it is zero point 0.7 moles per liter, and this is going to be zero point 0.9 moles per liter. Are you understanding? There.
Yep.
And now I'm trying to, mix these two solutions and have a look that, how much volume of HCl. So now in the beaker, I have taken such a solution. Such a solution, I have taken, let's suppose, 70 ml. And now I'm seeing, that how much NaOH I would be requiring to to neutralize the HCl. What am I finding? How much NaOH I would be requiring to neutralize HCl. Are you understanding?
Yep.
So what is that? Just understand. So just have a look here. Now the question is that the kind of solution that you have right here, what is that? It has 1000 ml of solution will have zero point 0.7 moles of HCl. So 1 ml will have zero point 0.7 moles over 1000 moles of HCl. Are you understanding?
Yep.
If I have 1000 ml of solution, so in that ml solution, I will have zero point 0.7 moles of HCl. Definitely there is some water
Yep.
as well, but the amount of HCl is zero point 0.7 moles. That's the concentration we have taken. So
Yep.
in 1 ml solution, how many moles of HCl do you think you will have? You will have zero point 0.7 over 1000. So
Yep.
in 70 ml solution, in 70 ml solution, how many moles of HCl actually you are carrying? You're carrying zero point 0.7 over 1000 into 70. So this cancels. You understand? So you have 4.9 over 100. So it will have 0.049. moles of HCl I have in this particular solution. See, understand, when you go to a sweet shop, have you ever seen a sweet being formed, Dia?
Yep.
So they have these kind of sugar syrups, big tubs of sugar syrups, right?
Mm-hmm.
But is it something that, they have this kind of big tub of sugar syrup, and if you take out a glass of sugar syrup from that, so in this glass of sugar syrup, would you have the same amount of sugar that you have in the group, in the tub? No. Here they must have had 30, 60 kgs of sugar into it. But the amount of sugar that is coming in this glass would be just, let's suppose, 10 or 15 grams, isn't it?
Yep.
Because you're not taking out the entire solution into the glass. You are taking out a part of the solution into the glass. I hope you're understanding.
Mm-hmm.
You understand my point.
Yep.
So that is the concept. That is the concept. So what do you understand from this particular concept? Understand. My point here is that, when we are talking about the solution, I am giving you the data about 1 liter solution, but not necessarily that I am taking only full liter of solution into the beaker. In this beaker here, I might take only 70 ml solution, only 70 ml. So 70 ml will not have all the moles in it, because I have the data about how many moles of HCl you have in 1 liter. Are you understanding my point?
Yep.
You understand how many moles
Yep.
of HCl we have in 1 liter? I hope you're understanding. So I have not taken one full liter of solution. I have taken only 70 ml. This is a point to understand properly. So you say that, 100 ml of solution will have this much moles of HCl. So 1 ml solution will have this much moles of HCl. So 70 ml solution will have 0.09 moles of HCl. Understood or not? Diya.
Yep.
So basically, this solution that I'm talking about, this solution has 0.049 moles of HCl. Understood or not?
Mm-hmm.
You understand? So I could have done it
Yes.
straight away. I could have done it straight away. What? That, ma'am, molarity, this is the concentration into volume. I could have simply done what? The concentration into the volume, because that's what I'm doing. The concentration 0.7 into the volume. And volume divided by 1000 would mean that I have converted the volume into liters.
Yep.
So now from here, can I just tell me clearly that, the total moles that the solution is carrying into itself is basically equals to concentration into volume, and volume should be in liters. And which volume am I talking about here? The volume that I'm using in the experiment, because the concentration shall always be over 1 liter. That, how many moles of solution would be present in 1 liter. I hope you're understanding.
Yep.
Any doubts? Right? Now my
Mm-hmm.
question to you is that how much liters of NaOH you would be requiring to neutralize this solution, 70 ml HCl. So from this, you tell me one thing, Dia. I'm rubbing off this part, right? Right. So now you understand what is going to happen. What is going to happen? Just tell me. That here, if we have 0.9 moles per liter, what does that mean? You tell me. What does that mean? It means that, ma'am, I need zero. If 1 moles of HCl needs 1 mole of NaOH, thereby 0.049 moles of HCl would require 0.049 moles of NaOH. That's what my ratio is telling me. You understand? So I know from the equation that 1 mole HCl requires 1 mole NaOH. So 0.049 moles of HCl would require what? Would require 0.049 moles of NaOH according to this equational ratio, isn't it, Dia? Are you understanding? Hello? So do you understand what I'm saying?
Yep.
That 1 mole of HCl, if it requires 1 mole of NaOH according to the equation, so I have 0.049 moles of HCl.
Yep.
So 0.049 moles of HCl would require what? Would require 0.049 moles of NaOH, isn't it?
Yep.
And that would mean what? That would mean that 0.049 moles of HCl was actually present in 70 ml. So I have to now find out that how much volume of NaOH I would be requiring. So you say this now. You say that ma'am, 1000 ml of solution. So I would say this way. I would say 0.9 moles of NaOH is present in 1000 ml solution. Yes or no? So 1 mole NaOH shall be present in 1000 over 0.9. So 0.049 moles of NaOH shall be present in what? 1000 over 0.9 into 0.049. Are you understanding? So you remove the
Um.
decimals? You understand the
Yep.
again I tell you this if you're not understanding this part, an easier version for this also I can tell you, which you would get straight into your head. The question is like this. You will write it down this way. Do you know that total moles is equals to concentration into volume.
Yep.
So I need 0.049 moles of NaOH,
Mhm.
and that should be equals to the concentration. The concentration is what? The zero point 0.9 for NaOH. I do not know the volume. Right there.
Yep.
So volume required for NaOH would be what? 0.049 over zero point 0.9. And if I
Yep.
remove the decimal, I will put a 10 here. If I remove this decimal, I will put 1,000 here. So volume of NaOH shall be what? It should be what? 49 into 10 over 9 into 1,000. So 1 0 cancels 1 0. And I will have somewhere around 4.9. So 9 5s are 45. And then 40, 9 for the 36. 5.4 over 100. So I will have basically 0.054 liters. 0.054 liters would be how much? Tell me. 0.054 liters would be how much? You tell me.
Um.
54 ml.
54.4. Yeah.
So basically 70 ml of HCl here could be neutralized by 54 ml of NaOH. Why so? Because both of their concentrations were different. NaOH was more concentrated. Can you see that? You had more NaOH per liter than HCl per liter.
Yep.
So that is why if NaOH solution is more concentrated, you would require less volume of it to neutralize the more quantity of HCl solution. Do you understand my point?
Yep.
Do you understand?
Yep.
So it's not necessary that you would require 70 ml, 70 ml of each. 70 ml, 70 ml of each you would be requiring only when their concentrations are same. But if their
Yep.
concentrations are not same, then the one which is more concentrated, whose amount is more per liter, that concentration you would be requiring in the less quantity to neutralize the one which is present in the more quantity. Understood or not?
Yep.
So this is the basic concept of neutralization. So when I am dropping drop by drop, here in this concept, if I'm dropping the base from the burette drop by drop, So obviously you understand what are we going to calculate? We're going to calculate the volume from the burette. So you see over here what is going to happen? Just have a look here. So if for example we have the zero marking, so the liquid would be filled in something like this, and that liquid falls in drop by drop, drop by drop, drop by drop. So don't you think the level will come down? And
Yep.
after a while, now the liquid starts from fourth. Initially, it had come from 0 to 4. So that means what? Tell me. That means what? Earlier, the liquid was up till the 0 mark. And now it has come down to 4 mark. That means 4 ml of liquid has flown into the beaker. Are you understanding?
Yep.
Any doubts in this? Tell me.
Nope.
Understood or not?
Understand.
So that's the concept. Okay?
Yep.
And then if you keep allowing the liquid to flow down, the level then comes down again more. The level comes here. That means what? Now the level is at the red point. So I can now measure what value it is right here. Let's suppose it is 10. So that means now from 0 to 10, that means 10 ml has flowed down. I hope you're understanding my point.
Yep.
So that is the concept. That is the concept. So what do you understand from this part now? What do you understand from this part? My point here would be that if you're falling from here to the down part, you understand?
Mm-hmm.
So from the burette, these calibrations will tell you how much volume you are requiring to neutralize fully the amount of acid that you're taking inside the beaker. Are you understanding the point?
Yep.
Okay, that is the concept here. That is the concept. Are you understanding?
Yep.
So that's how the concept should be. Now, if how do you know that here neutralization is complete? Now that's the point. So here we check for the end point. Now, how do we know where is the end point? So what do we do? You remember we added a indicator here.
Yep.
So what is this indicator for? Understand. So let's suppose here, Dia, we had 10 moles of HCl. So gradually, as the base is falling down, so let's suppose in one drop, 1 ml is comes inside, 1 mole comes inside. Let's suppose that way. So do you understand that, when we have 10 moles of HCl in the beaker and 1 mole base falls into it, do you understand that this 1 mole base has neutralized only 1 mole acid from the 10 moles of acid?
Mm-hmm.
So that means 1 mole of salt is formed and 1 mole water is formed and 9 moles of acid is still left to neutralize. Are you understanding?
Yep.
Then again 1 drop falls inside. So when again 1 drop falls inside, again that means 1 mole extra base we have added inside. So now out of 9 moles left, 1 mole again is left. So now 8 moles of acid are left over.
Yep.
Do you understand my point?
Yep.
Any doubts in this?
Nope.
What does that mean? What does that mean? Tell me. That
The
means, yeah, tell me. What does that mean?
it'll just show how
So we will have
it'll
8
show
moles
how
of,
much volume of
now 8 moles of acid would be left behind and 2 moles of base has neutralized 2 moles of acid and so on. So if 3, 4, 5, 6, 7, 8, 9, 10 drops fall of the base inside the solution, then I would say that, in the beaker, 10 moles of acid and 10 moles of base have been added, and which is why the neutralization is complete. And now you understand. Till now, we would have 10 moles of salt. Yes or no, dear? And this 10 moles of salt, when you have
Mhm.
phenolphthalein added, so phenolphthalein shall remain colorless because phenolphthalein remains colorless in the presence of salts. You understand? But now what is happening? You understand? What is happening? In the presence of a extra little bit, very minute amount of base falling inside, because we can control the closing and the opening with the cork. When a little
Mm-hmm.
amount of base extra falls inside it, the phenolphthalein colors changes into pink, and it remains permanently pink. You understand? It remains
Yep.
permanently pink because initially when it was falling, what was the scenario? Tell me, what was the scenario? Here we had 10 moles of acid and some amount of phenolphthalein. So this yellow shading is phenolphthalein, let's suppose. And this phenolphthalein, it changes color only when it has an excess base. You understand? Only when it has an excess base. Understood or not?
Yep.
So what does that mean? You understand? When it has 10 moles of an acid and you keep adding a base, so the moment